So let's move on now to a few more examples where we will also analyze the end behavior and not just the domain and range. Let's look at the domain of our first example. As this arrow indicates to us, we go further and further to the left, so there is no lowest value. We go to negative infinity, and this arrow tells us we're also going to go to positive infinity. So in set notation, we describe our domain as follows: open braces, x such that, and you've seen this before, x is an element of, or you could also say any element of the real numbers. In interval notation, we write parentheses, never brackets when we have the infinity symbol, right? Negative infinity, comma, positive infinity, close parentheses. Now let's look at the range. The range seems to go down until negative infinity, which is indicated by this arrow, and also by this arrow. But there is a highest point, the greatest value, which is right here, and that value seems to be positive 5. So for our range, we will write in set notation y. Always remember that when we talk about range, we talk about y values. When we talk about domain, we talk about x values. Y such that y is less than or equal to, up here, positive 5. And in interval notation, we will say open parentheses, negative infinity, comma, 5, closing brackets. 5 is part of our range. Now, let's look at our end behavior. As x goes to negative infinity, what happens? Well, f of x, in other words, our y values, also go to negative infinity. And as x goes to positive infinity, over here, f of x continues this time to also go to negative infinity. Let's look at our next example. The domain seems to go down to negative infinity and up to positive infinity. So we write x such that x is any element of the real numbers. Or in interval notation, we would say open parentheses, negative infinity, comma, positive infinity, close parentheses. Our range is similar. Our range goes also from negative infinity to positive infinity, again, this being indicated by our arrows. So in set notation, we will write y such that y is an element of R. And in interval notation, negative infinity to positive infinity, and both times we use parentheses. Our end behavior is a little different than in the previous example. As x goes to negative infinity, f of x, or you can also say y, also goes to negative infinity. And as x goes to positive infinity, f of x goes in the same direction, in other words, also goes to positive infinity. So try out that next example by yourselves and check the answer with mine. You don't have to do the end behavior, just focus on domain and range. Hopefully your solution looks like mine. And now let's go to our last two examples where we have discontinuous domains and ranges and see how we analyze and describe these. So our domain goes from here, and then if we follow that graph, we see that we get to this point, although the open circle indicates the point itself is actually not part of it. And then there's a gap, and we actually continue here onwards, and then the arrow indicates to us that for the rest of it, we're going to keep going until positive infinity. This is what we call a discontinuous domain because there is a gap in here that's not part of the domain. And we have to describe it by describing each part separately, but together in one answer. In other words, using set notation, we will write x such that -4 is less than or equal to x, which is less than but not equal to, remember the open circle, +1, or, this is an inclusive or x is greater than or equal to 2. In interval notation, we are also going to describe both parts of the domain by writing open brackets -4, comma 1 closing parentheses. 1 is not part of the domain. And now we use a symbol that you know from geometry. It looks like a U, and it's the symbol that's used in logic for an inclusive OR. And the second part is, as we have been doing it so far, open brackets 2, comma, positive infinity, and parentheses. The range also looks a little complicated at first, but let's go through it step by step and we'll see that it's actually not that bad. We start down here. That seems to be the lowest value of our curve, although again with the open circle, the value itself is not part of the range. From there we keep going upwards, and then we get to this point, and where we see that we have a closed circle. This point is part of the range, and at the same point the second curve starts, which then continues to go all the way up to positive infinity. And that means that we actually do not have a gap in this range. It's a continuous range, and we can describe it the way that we have been describing these in set notation. Y such that -4 is less than, not equal to, due to the open circle, y, and that's it. In interval notation, we will write open parentheses -4, comma, infinity, and another set of open parentheses. Go ahead and try that next example by yourselves and watch very carefully for the open and closed circles. Hopefully you came up with the same solution as I did. The domain is x such that x is an element of the real numbers. Even though we have two open circles at the same value, we also have a closed circle, and that closed circle closes the gap, so there is no discontinuous domain. In interval notation, we'll write open parentheses, negative infinity, comma, positive infinity, close parentheses. And for the range, it's y such that y is greater than, but not equal to, -7. In interval notation, we'll write open parentheses, -7, comma, infinity, close parentheses. That's it for today's class. I now want you to spend a few minutes and, in your own words, no more than 20 words, write down the most important things about today's lesson. And I will see you in class.